Welcome to my session. My name is Sylvia Celedón-Pattichis. I am a professor of bilingual, bicultural, and mathematics education at the University of Texas at Austin. And I'm here today speaking to you as an English language learner myself. I grew up in Mexico for up to about age 8, and then went to California and to Texas, where all my schooling was done there. And I had teachers who influenced me to continue my career path in bilingual and mathematics education. It took quite a bit of intervention to be able to access rigorous mathematics and also continue my language development in both Spanish and in English, and to continue to thrive in both of those areas. As a result of that support from teachers, I was able to continue my education at the University of Texas at Austin, where I was able to study and bilingual and mathematics education, and taught mathematics myself at the high school level for 4 years, at the same high school that I graduated from in Rio Grande City, Texas. My areas of research are in language and cultural influences on the teaching and learning of mathematics. And that area was inspired by my own experiences as a bilingual learner of mathematics, and going through the schooling system as a second language learner of English. And so today, I would like to share a kindergarten study that we conducted as part of a project that was funded by the National Science Foundation. We would like to thank NSF for their support of the Center for the Mathematics Education of Latinas, Latinos, and the collaboration and support of our team. It's a reminder, any opinions, findings, and conclusions or recommendations expressed in this material are those of the authors and do not necessarily reflect the views of the granting agency. I would also like to specifically thank Erin Turner, Alan Tennyson, Edgar Romero, Rick Kitchen, Mary Marshall, and Sandra Musanti, who were part of the Semela research team. The session objectives for today, I would like to present some background on multilingual learners and mathematics, introduce the kindergarten study, and then share examples from the field to illustrate how we collaborated with teachers to co-design mathematics lessons that centered rigorous mathematics and language development, and then generate discussion through questions and answers. Also, as a reminder, I will share 3 resources in the resource room. Those will be accessible to be downloadable from the resource room. And one of those pieces is a more recent collaboration with one of the teachers who was actually an apprentice, a student teacher working with Ms. Arenas. Her name is Carla Ceballos, and so that piece will be available there. So as part of the Semela, I want to talk about the Center for Mathematics Education of Latinos, Latinas, Latinos. And what that center did was it brought together faculty members with this integrated knowledge to understand language, culture, and mathematics. So we had experts in language, culture, mathematics education, and mathematics. Some of the guiding principles of the center were holding high expectations for students' academic achievement and strengthening the native language, not only on transitioning students to English, and also understanding language and culture as intellectual resources rather than viewing these as deficits, and also promoting multilingual learners' participation in mathematics conversation rather than focusing on decontextualized vocabulary. Dr. Moscovich's work has been really critical, and also Dr. Kisti's work in understanding what we mean by this. So some background on multilingual learners. As of 2020, 56% of the world populations spoke more than one language. In fact, 13% of the world populations speak 3 languages fluidly. And in the US, there are about 4.5 million multilingual learners, and more than 3/4 of this student population speak Spanish as their first language. The US hosts the largest Spanish-speaking population in the world after Mexico. When we think about young children and problem solving is integral to learning mathematics, and often there's an underestimated capacity of young children to be engaged with problem solving. In terms of young Latinx students and problem solving, we know that Latinx students represent the fastest growing group in public schools. Nearly half of them are bilingual learners, and there is a persistent gap in opportunities between Latinx students and white and Asian counterparts. Young Latinx and problem solving, we know that there's unequal access, low income, and culturally and linguistically diverse students are overrepresented in basic skills-oriented classrooms. And there's trends that apply to children as young as kindergarten and young Latinx and African American children in particular. So given qualified teachers and access to rigorous problem-solving instruction, low-income students of color have demonstrated high levels of achievement. And so what I would like to share with you now is the kindergarten study that we focused on. The research focus was what instructional practices support young Latinx in mathematical problem solving. And given ongoing opportunities to solve problems, what is the nature of students' learning? The theoretical perspectives that we drew from for this study were sociocultural perspectives of learning, where we know that language plays a critical role in mediating the learning that happens, and also drawing on discourse and learning mathematics, the funds of knowledge work, and also cognitively guided instruction, opportunities to learn, where we look at the time on task, the quality of tasks. Those are very relevant to this study, as well as opportunity gaps. And we are moving away from achievement gaps. The opportunity gaps really questions the systems, the schooling systems, and what they're doing for our students and our communities. So in the Samela kindergarten study, to give you some context, it happened in a state where there are at least 2 or 3 articles in the Constitution that where Spanish is a medium, can be used as a medium of instruction. And so in this setting, we focused on 3 kindergarten classrooms with low SES schools that served predominantly Latinx student populations. As you can see from the table, Ms. Arenas taught mathematics in Spanish. Her students were all Latinx, emergent bilinguals in a dual language class. Ms. Field had both native English and native Spanish speakers. It was an ESL class, English as a second language, and she was certified to teach ESL. And Ms. Perales had both groups of students. It was a bilingual class where she taught mathematics in both languages. We also followed a situated professional learning with teachers where we co-designed the lessons, we co-taught the lessons, we adapted to the realities of the teachers and the schools and the students, the communities that we worked with. So as part of the methods, we did conduct biweekly classroom observations. Those are videotaped, transcribed, and coded. We had 2 lessons in the fall and 3 in the spring from each classroom. We also conducted pre and post clinical interview assessments. Those were conducted with 7 students from each classroom in October and 15 from each classroom in May of the school year. And then we administered the assessments in the students' dominant language. They got to choose which of the languages those assessments were conducted in. And we also coded for strategy use and whether answers were correct or incorrect. And these tasks were based on Carpenter et al. Study of kindergartners' problem solving. So as you can see from this table, these were some sample assessment items. And you can see the pre-assessment version and the post-assessment and the types of problems, some of the types of problems that we included. The first set includes addition type problems and also multiplication type problems, division. And as you can see from the table, we used slightly larger numbers in the post-assessment. In the pre-assessment results that we found, we noticed that most students could count a small set of objects, typically under 10. Half of the students solved basic addition and basic subtraction problems. And multiplication, division, and compare type problems were much more challenging for students in the pre-assessment. And that was 14%, 25%, and 0% respectively. We want to note that some students could not count past 2 or 3, and a few of the students could count past 15. And those were some of the findings that we got in the pre-assessment. So what I want to show you is a video case that illustrates how the work was conducted with the teachers. And I highlight Ms. Arena's class. This is in March. Maybe some of you have seen this video clip before because we tend to go back to this video clip and analyze a lot of her practices and also Carla Ceballos's practices, who was mentored under Ms. Arenas. And Ms. Arenas typically began her problem-solving lessons with, fíjense, amorcitos, pues les voy a contar una historia. Listen, my little loved ones, I'm going to share a story with you. And the way that she did that was to really draw from familiar context of the students' surroundings. There was a lot of co-construction of the story. And so if you can imagine, like, let's say she was talking about birthday parties. And in the Latinx communities, there's piñatas, there's candies in the piñatas. And so she really used that as a context to co-construct these stories with the students. So she would ask questions like, what type of piñata do you want it to be? Like, what shape? Do you want it to be an animal shape? The students were given agency in co-constructing those stories with her. And so they got to decide what numbers they wanted to use, how many candies they wanted the piñata to have. And that's what she really used as a context to engage the students in problem solving. And so what was powerful about that too is that we get to see the students and her constructing different types of problems for students to engage in. So for example, one problem that did come up was a compare type problem with the difference unknown, where the students were comparing how many candies each student had, and set up the context for comparison type problems. So the problem that I'm going to share with you is a multiplication problem. She says, I bought 4 toy horses at the store. I put them all in a bag to take home. How many feet were there in the bag? And so this is a whole group problem-solving session. So as you watch the video clips, what do you notice and wonder about? Please take some note of that, and hopefully that'll give us some points to engage in discussion after this presentation.
Vamos a hacer otra historia. Escuchen esta historia. Fíjense, yo fui al almacén y compré 4 caballitos. 4 caballitos. ¿Cuántas patas? Los metí en una bolsa. ¿Cuántas patas tendré en la bolsa?
4. 2. 12.
Tengo 4 caballitos.
16. 12.
A ver, señor Eduardo.
16.
Eduardo dice que tenemos 16. ¿Cuántas dices tú, Briana?
15.
16. Ah,
15.
tú dices 15. Vamos a ver. A ver, Eduardo.
Yo 3.
Porque tengo 4 caballitos, no 3. Tengo 4. A ver. Fíjense cómo lo hace Eduardo. Piensen para mientras.
Yo pienso que...
Tengo 4 caballitos y los metí en la bolsa. ¿Cuántas patas tiene cada caballito?
Yo pienso que tiene 3. 1, 2, 16.
Ajá, yo creo que...
16.
Muy bien, Eduardo. ¿Cuántas patas metí en la bolsa? ¿Ah? 50. 8. Muy bien, ¿cuántas patas ponga? ¿Cuántas? Cada uno 4, pero ¿cuántas en todos? ¿Todos juntos cuántas? ¿Cuántas contaste ahorita? Muy bien. Okay. Ajá. Ah, muy bien. Muy bien. Todos miren. Wow, Eduardo.
16.
Muy bien. Un aplauso a Eduardo. Miren lo que puso Eduardo aquí. No se ve bien el 16, pero Eduardo puso 4 veces 4 es igual a 16. Ahora fíjense, contemos, ¿cuántos caballitos tengo? 1, 2, 3, 4. ¿Cuántas patas tiene cada caballito? 1, 2, 3, 4. Cada caballito tiene 1, 2, 3, 4. 1, 2, 3, 4. Este tiene 4, este tiene 4, este tiene 4 y este tiene 4. Cuando las cuento todas, contémoslas. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. ¿Cuántas hay?
16.
Son 16. Ahora podemos hacer una suma larga. 4 más 4 más 4 más 4 es igual a
16.
Es igual a 16. Muy larga la suma. 4 más 4 más 4 más 4 igual a 16.
So there's a lot to unpack in this video, and there's so many ways that we could go with analyzing the video clip. One, I must say that this student, we captured the moment where he was appropriating the multiplication symbol to make meaning of multiplication. And it's the first time that he's thinking about using it. This student was also thinking with much higher numbers. When we did the pre and post assessments, we found out quite a bit about this particular student. And one of the practices, again, was the storytelling conversations. that familiar narrative structure of the story scaffolded students' explanations. And teachers use that narrative frame to guide students as they learn to explain their thinking. The stories help the students learn to represent mathematical ideas and to connect multiple representations. And the teachers continually refer to the story to help students make sense of their representations. Another practice that we found to be key was the positioning of students to thrive as problem solvers. You can look at Cheval and other colleagues' work, more recent work on this. But positioning really played a key role, and we also saw it in the ESL classroom, where the teacher did not share the language with the students, yet she was still positioning students who were at beginning stages of language development. Even if they were pointing at objects or at a table, she would make sense of that pointing, leveraging the pointing to make sure that the students had an opportunity to go up to the board and explain, share their thinking with their peers. So I think that's the more that students are given those opportunities, the less shy they become. Also, that's what we have noticed in the classrooms, across the 3 classrooms. The strategic use of positioning and questioning, positioning students as competent problem solvers who have important contributions is key. Also, extending a series of open-ended questions to invite students to share their thinking, and also alternating between focused and more open-ended questions when students struggled to explain their ideas. We noticed all of those patterns again across the 3 classrooms, where teachers, if they wanted to get details of the quantities represented in the stories, they would always have students go back and retell the story multiple times if needed to be able to get students to make meaning through close-ended and more open-ended questions. So most of that work of the oracy, the oral language development, occurred in the fall, and it continued into the springtime also by having students retell their stories. In the springtime, teachers shifted to working with students on their written expression as well. So taking them from the oral development to the written development. And they worked with having students create their journals. This gave them much more agency to the students to then become problem posers themselves. So they were going from problem solvers to problem posers. If you can see in this example, the student in her journal in Spanish, I translated this, and she says, I had 12 and my mom cut 3 flowers, and I now have 9. And so here you can see the pictorial representation. There's a lot of thinking of in-depth understanding of the structure of the problem. The drawing represents the problem and the solution. The writing provides a storyline for their own number stories. And you can see the pictorial representation, symbolic, and the written. This is an example of a partitive division type problem where the student has, I had 8 cookies and I gave 4 to my friends. The drawing shows how she distributed 4 cookies to each friend, and the algorithm shows that she didn't have any left. She uses her language resources and knowledge of writing to represent the problem. So here we've written about this in multiple ways, but across the 3 classrooms again, we saw the oral language development, pictorial representations, symbolic representations, the written, all of those intertwined, and making sure that the students, to support the students in making that transition from the concrete to the abstract, and emphasizing the need to make connections among those representations. In the content analysis that we did of selected lessons from 3 kindergarten classrooms, we noticed that in Ms. Arena's class, students had Definitely the mean number of problems per lesson was higher. You can see that there were about 5 problems in contrast to the other classrooms that did about three to 4 problems on average. And the mean lesson length in Ms. Arena's class, there was more time devoted to those problems. The number range was higher, also from 1 through 20, using those numbers in the problem types. And then, as you can see, that varies across the 3 classrooms. And the problem types covered as well. You can see that there's more variety of basic to more challenging type problems used in Ms. Arena's class. This is a table outlining how Ms. Arena's students compare to the Carpenter studies, and we realized that the number is smaller, the number of students, but we still wanted to provide that comparison in terms of how students performed. And as you can see, some of those numbers are higher also in Ms. Arenas and lower in some of the more challenging type problems, but still considerable gains. Overall, in those 3 classrooms that we observed, as you can see, what we want to highlight here is that most students could solve the more basic type problems, and about half were able to solve even the most challenging type problems. Correct versus valid. Correct means they got the correct answer. Valid means they were using a valid strategy, but they may have miscounted towards the end or have done some minor mistake towards the end. And what I would like to share next is a video clip of one of the pre-post assessments that we did with one of the students, with the students. And here you can see what I want you to notice is the mathematical thinking gains in understanding, and also the language development that happens between October and May.
Daniela está poniendo velitas así, en un pastel de cumpleaños. Ahora hay 4 velitas en el pastel.
1, 2, 3, 4. 1, 2, 3, 4.
¿Cuántas velitas más tiene que poner Daniela para que haya 7 velitas en el pastel?
1, 4, 5, 6, 7.
A ver, ¿cuántos tienes ahora?
1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7.
¿Ahora cuántas velas tienes en el pastel?
7.
7. ¿Cuántas velitas más tuviste que poner? Porque en el principio tenías 4. Había 4 en el pastel. ¿Cuántas más pusiste?
6.
¿Cómo sabes?
Pensé
¿Qué pensaste?
que tenía 6.
Ah, ok. ¿Dónde están las velitas que estaban en el pastel primero? ¿Te acuerdas cuántos había?
4.
Había 4. ¿Y estos?
6.
¿Son 6? Ok. Así que para ver si yo te entiendo muy bien. Primero tenías 4 y luego pusiste estos para hacer ¿cuántos en total?
6.
¿Son 6? A ver, cuéntalos.
1, 2, 3, 4, 5, 6.
Querías tener 6.
1, 2, 3, 4, 5, 6.
¿Y 6 porque cuántos años vas a cumplir tú?
6.
6 porque vas a cumplir 6 años. Aitana quiere comprar un avión que cuesta $11. Aitana tiene $7. ¿Cuántos dólares más necesita Aitana para poder comprar el avión?
Necesito
otra vez. Aitana tiene $7. ¿Cuántos dólares más necesita Aitana para comprar el avión?
Dos.
A ver, ¿cómo lo hiciste? Explícame lo que hiciste ahí.
Primero Aitana quería comprar un avión que cuesta $11
Ajá.
y le faltan 4
¿Cómo supiste que le faltan 4?
porque quité los 7 y le faltan 4.
Ok, te entiendo muy bien.
So in this video clip, we see that context matters. The student wanted for there to be 6 candles, not 7, because it was her birthday coming up. And so she knew what she was doing, even in the pre-assessment. And then we see the development of language and mathematics towards the end. I hope you were able to make some notes about that. But some opportunities to learn that we see in the case of Ms. Arenas is that students had more opportunities to solve a broader range of problems. Like I said, more time was spent on problem solving. There was an equitable distribution between basic and challenging problems. And all of Ms. Arenas' students were taught mathematics in Spanish. And twice as often, Ms. Arenas used an informal storytelling manner to present different problem types. Some caveats is that Ms. Arenas' students were more successful on some problem types. However, students across all 3 classrooms showed remarkable growth compared to what other studies might predict. We highlight differences only to describe how expanded opportunities may have resulted in even greater achievement for these students. And in comparison to other studies, students solved a much broader range of problems than the national assessment of 22,000 kindergartners would predict. And this was done by the National Center of Education Statistics, where 18% of the students solved addition and subtraction, and 2% solved basic multiplication and division. And performance on easiest problem types was comparable to that of kindergartners in Carpenter's study. Students were less successful on more difficult type problems. But we also want to make note that it is not clear what kind of problem types there were in the NCES study. However, we do know that it's addition, some of the basic operations, or what kind of instruction was used in those classrooms. Some recommendations include a broad range, making sure that we include a broad range of mathematics problem types, using storytelling to vary the context of the word problems by using your own students' names, friends' names, relatives, using objects or places that are familiar in students' communities, using the journals to encourage students to post problems in writing and represent the solutions pictorially, symbolically, and written. They can pose these problems to their friends or take them home to pose to their own families. Using the students' native language to persevere in solving word problems, including critical multilingual awareness. And I think that awareness includes understanding the historical oppression of certain groups and how schools and societies have reproduced dominant ideologies of monolingualism, and how, and I quote Garcia on this, how language is socially created and thus socially changeable to give voice and educate all students equitably, end of quote. I think in this case, we also should consider the work of translanguaging that Garcia and many other scholars before her have also talked about. It's an approach that includes students' full linguistic repertoires, and that also encompasses other communicative means and context for meaning making. So I wish you the best as you continue the work to make classrooms more equitable for all of your students. Thank you. I think one of the questions that always comes up with the students that are in my methods class, my math methods class right now, is that they tend to be in classrooms that teach mathematics in English. And so even though we talk about embracing different languages, what can they do to make sure that they're also addressing their student populations? One of the things that that we often discuss, and we also draw from the work of Dr. Melissa Adams Corral. She has experience teaching in Austin, Texas, and in bilingual classrooms where that is the case, that there's policies that where students can only teach mathematics in English, and we talk about how that creates injustices for the student populations in the classrooms. And so then as a teacher, you have to decide whether you continue reproducing those injustices or you change the path of what happens in the classroom. And something that we discussed that is critical is that we need to navigate as bilingual educators that space by using both languages. It's going to entail using translanguaging at times. It's going to involve creating the work in both English and Spanish so that it is accessible to both student populations, and being able to make sure that that we continue the work and that we begin with different problem types that students are not used to seeing. In this case, posing problems, starting the class with something like join, change, unknown type problems, posing those at the beginning and asking students how you might solve those. And also something that we talk about is discussing how we need to better engage students with that work. So I would invite you to reach me via email if there's any questions or other resources that you need to support the work. I would be happy to do that, and thank you for joining this session.